Hello everyone. Our lesson is about the sampling distribution of the sample mean. Let us have this example. A population consists of 5 numbers, 2, 3, 6, 10, and 12. Consider the sample size 2 that can be drawn from this population. Again, we are required to answer this question. Okay? How many possible samples can be drawn, and we are asked to construct the sampling distribution of the sample mean. First, let us answer how many possible samples can be drawn. To answer this question, we will use this formula, combination of the population size taken from the sample size, n. Okay? So in this case, there are 5 numbers in the population and sample size 2. Okay? We will substitute these numbers from the formula. Okay? So population size n is 5 and the sample size 2. Okay? So we have the formula population n factorial over sample size n factorial multiplied by n population n minus the sample size n factorial. Okay, so 5 factorial over 2 factorial times 5 minus 2 factorial. Okay, so we got 5 factorial over 2 factorial times 3 factorial. Okay, so what is a factorial means? Okay, it is the number where you will multiply the next descending number or next descending whole number. Okay, so we will multiply 5 by 4 by 3 by 2 and by 1. So we have 120. Multiply 2 by 1 and multiply 3 by 2 by 1 and then multiply both, we will have 12. So 120 over 12, we have 10. Okay, so the possible samples to be drawn is equal to 10. Okay. So we will now construct the sampling distribution of the sample mean. Okay. List all the possible outcome. Okay. List all the possible outcomes. So how many possible outcome, okay, that we will list? So we have found out that there are 10 possible outcomes. So we will list 10 possible outcome. Okay. Remember that the outcome may only be listed once. Okay, it may only be listed once. Okay, and then get the mean of every sample. Okay, so here are these samples listed on the outcome column, and you will get the sample mean in each row. Okay, let us have the first row, which is 2 and 3. The sample mean is equal to 5. How do we get 2.5? Okay, 2 plus 3 and then divide by 2 because the sample size is 2. Okay, so we will have 2.5. 2 plus 3 is 5 divided by 2, 2.5. Next row, 2 and 4. Add 2 and 4, you got 6, and then divide by 2. Sample mean is 3. Next, 2 and 6 plus, okay, add mo sila, and then you will have 8 and divide it by 2, you'll get 4. Okay, and so on. Okay, so to get the probability or the sampling distribution, okay, just add all the number of frequency. Okay, you count the number of frequency over the possible outcome. Okay, so get a list all the sample mean. So on the left table listed on the sample mean, you have 2.5. So we will count how many 2.5 appear on the sample mean. Okay, so there are only 2.5. Okay, next 3, count all 3 on the sample mean. So there are only 3. So that would be 1 over 10 or 0.1. Next row is 4. Sample mean 4. Count how many 4 are there. Okay, so there are only 1. So the probability is 1 over 10 or 0.1 and so on. Okay, so that's it for the sample mean or the probability or the sampling distribution of the sample mean. Okay, a sampling distribution of sample mean is a frequency distribution using the means computed from all possible random samples of a specific taken from a population. Okay, let us have another example. Okay, a population consists of 6 numbers: 1, 2, 3, 4, 5, and 6. Consider the sample size 3 that can be drawn from this population. Okay, requirement again, how many possible samples can be drawn, and construct the sampling distribution of the sample mean. Okay, so to answer this, the first question, how many possible samples can be drawn? Again, we use the formula, the combination of n taken the sample size, the combination of the population taken from the sample size. Okay, so in here, the combination of 6 taken 3 at a time. Okay, so how many samples or possible outcome do we get? So there are 20. So how did we get 20? Substitute the given from the formula. So as you can see, population size n is 6 and the sample size n is 3, and then substitute it, 6 factorial over 3 factorial multiplied by 6 minus 3 factorial, and then we have 6 factorial over 3 factorial times 3 factorial. Okay, so sundan lang yung formula. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. 3 times 2 times 1, and then multiply it after you get the answer. Okay, so 6 times 5 times 4 times 3 times 2 times 1 is 720. And 3 times 2 times 1 is 6. And then multiplied by 6, we have 36. So 720 over 36, we had 20. Okay, so the combination of the population size 6 taken the sample size 3 at a time is 20. Okay, then we will construct the sampling distribution of the sample mean. List all the possible outcome and get the mean of every sample. Okay, so we know that there are 20 possible outcomes. Okay, so we will list all the possible outcomes. So there are 20 possible outcomes. So we should list 20 possible outcomes. Okay, so remember that an outcome may only be listed once. Okay, so here is an example of the outcome. The first outcome would be 1, 2, and 3. Okay, and then get the sample mean of 1, 2, and 3. To get the sample mean, add 1, 2, and 3. That would be 6, and then divide by 3. You will have 2. Next outcome, 1, 2, and 4. Add. Okay, so you will have 7. Divide by 3. You will have 2.3. Okay, next, add 1, 2, and 5. And then divide by 3, you will have 2.7. Next, add 1, 2, and 6. Divide by 3, you will have 3. And so on. Okay, so here are all the possible outcome and their sample mean. Now, we will be constructing the sampling distribution or the probability distribution of the sample mean. Okay, so we will list all the possible outcome and the mean. Okay, so we will get the mean. Okay, so we have a mean of 2, and then count how many 2 have appeared. Okay, from the mean. So there are only 1. So that would be 1 over 20. Okay, 20 is the possible outcome of or all possible outcome. Okay. Next is 2.3. Okay. The mean of 2.3, how many 2.3 have appeared? Okay. There are only 1. So the probability would be 1 over 20. Okay. Next is 2.6. Okay. How many 2.6 have appeared in the sample mean? There are only 1. So the probability is 1 over 20 or 0.05. Next is 2.7. So how many 2.7 appear on the sample mean? So there are only 1. So 1 over 20 is the probability or 0.05. Next is 3. So how many 3 have appeared in the sample mean? There are 3. Okay, so the probability is 3 over 20 or 0.15. Okay, next sample mean is 3.3. How many 3.3 have appeared? So there are 3. Okay, so the probability is 3 over 3 or 0.15. Next is 3.6. How many 3.6 have appeared? Okay, there are 3. Okay, so the probability is 3 over 20 or 0.15. Okay, next is 4. How many 4 have appeared? So there are 3. Probability is 3 over 20 or 0.15. Next is 4.3. How many 4.3 have appeared? There are 2. Okay, so probability will be 2 over 20 or 0.10. Okay, next is 4.6. How many 4.6 have appeared? Okay, there are only 1, so the probability is 1 over 20 or 0.05. Next is 5. How many 5 have appeared? There are only 1, so the probability is 1 over 20 or 0.05. Okay, to know if this probability are correct, you just count this number and it must be 20. Remember, the probability is equal to 1. If it's not equal to 1, then it is not a probability. So, count the number and it should be equal to 20. Okay. 1, 2, 3, 4, and then we have plus 3, 7, plus 3, 10, plus 3, 13, plus 3, 16, plus 2, 18, plus 1, 19, and another 1. That will be 20. So 20 over 20, the probability is equal to 1. Okay, so that's it for our lesson, the sampling distribution of the sample mean. I'll see you in our next lesson. Bye.